So let's take a look now at example number 2. Let's see what we have here. Uncover Credit Card has determined that if a customer visits the company's website, there's a 30% chance the customer will register for the new Platinum that card. Let X be the number of customers. Okay, this is important. Let X be the number of customers who apply for the new card. Let's go back to rounding our decimals to 4 places, and suppose that we have 8 customers who are going to be visiting the website. Notice again, I'm following or going to follow exactly what the formula sheet highlights here. First thing I need to do is recognize, is this what is my random variable, and is it discrete or is it continuous? Well, here I'm told that X, my random variable, is the number of customers who apply for the new card. Okay, well, that's definitely discrete because I could count up on my fingers or using tally marks the number of customers who sign up for a new card. So it's definitely discrete. But so far we've covered 2 different discrete distributions. It could be generic, where I just make a table, or it could be binomial, where I get to use these binomial PDF and CDF commands. How do I know which one? Well, let's start by assuming it might be binomial, and let's check the conditions to see if that fits. In fact, that's what part A is asking. Does this scenario describe a binomial experiment? Well, let's check our conditions. Condition number 1. We're going to need to have a fixed number of trials. Do we have that? Well, yeah, there is a fixed number of customers who we're going to look at. So I'll say there is, or not is, but there are only 8 customers. So every time one of these customers comes to the website, we're going to be able to assess whether or not they sign up for the card and should be counted, or they don't sign up for a new card. Okay, what about number 2? If I look back on the formula sheet, it says that this experiment for each individual person should only have 2 outcomes. Well, that makes sense. My success here would be that the person signs up for the new card, and the failure would be that the person doesn't sign up for that new card. Okay, so I can kind of see there's one of 2 things is going to happen. They sign up or they don't sign up. Check number 3 says, are these trials going to be independent? Well, if I think about this one here, I could probably see that it's maybe pretty reasonable to assume that there's independence here. What one person does in terms of signing up for a card isn't necessarily going to affect what another person does. Now, typically in a question, I'll never suggest that assuming independence is a good idea. But for the sake of argument here, let's pretend that we actually know that this is definitely 100% independent events. So I can say events are independent. Check number 4 says, well, what's the probability of success? So the chances that somebody signs up for a card, chances that they sign up, we're told is going to be 30%. And so we ultimately have that P should be equal to 0.30. So again, we've met all of the conditions here to be a binomial experiment. And so we should definitely be able to answer this question, yes. So again, all we're doing is progressing down the formula sheet. We have the random variable. We know it's discrete. We now know that binomial seems to fit. So I should move to my next box, which means I better know what N and P are. And we've already established that. We said N was 8 and P was 0.30. Well, now I'm ready to visualize a table and to start using my calculator commands. Now, in part B here, I ask us to suppose that we have 8 customers and construct a probability distribution. Now, if I go ahead and construct this completely, it would take a long time. And so actually here, we're not going to go ahead and construct the entire table. In fact, I'm going to advise that you pretty much never construct the entire table, but you quickly think about its general form. Well, I should know what the different possible values of X are. If I'm going to have 8 customers who show up to the website, I should have 0, 1, 2, 3, 4, 5, 6, 7, or maybe 8 customers total that sign up for the card. Those are really the only options. I can't have more than 8 customers sign up for a card because there's not more than 8 customers who are even visiting. But across from those, I don't have their probabilities. But what I know is that using binom PDF, I can get those probabilities whenever I want. Let's see, though, how this would work by answering questions C through E. What is the probability that exactly one customer out of the 8 will sign up for a new card? Well, what you'll notice here is that I've kind of written out these values of 0 through 8 down in just a horizontal fashion to save space. And so now I can think about which of these numbers do I want to grab probabilities for. Well, if I want exactly one customer, then that means I want this probability, or the probability that would be positioned right here in the table. So in order to get that probability, I know exactly how to do this. First, I need to make sure I write down my probability notation. I want X, the number of customers to sign up for the card, to be 1. And I know I can get that by using the calculator command of binom PDF. I know that there are 8 customers, there's a 30% chance of success, and I want the probability across from the number 1. If I go to my calculator, I know I can enter this in and actually come up with an exact final answer, which I'm just going to go ahead and tell you I found as 0.1977. You could, of course, double check me on that. For part D, let's see what this says. What is the probability that at most 6 customers, okay, so at maximum 6 people sign up for the card? Well, that would mean that I'd be okay with 6 or less people signing up for the card. I'm okay with all of these different scenarios. And now I can think, well, that means up here in the table, I want a whole bunch of probabilities, and I'd like to add them all together. And of course, I can write that in probability notation as I want X to be less than or equal to 6. And I know I can easily grab this with a binom CDF, where I have 8 customers, 30% chance of success, and I want to stop at the value of 6. If I go ahead and I type all this into the calculator, you could double check me, but I get the answer of 0.9987. Let's take a look at this very last one here in part E. What is the probability that at least one customer, so 1 is the least number that I want? Okay, then that means that I want all of these options. I want to find the probabilities associated with all those x's and add them all together. Now notice again, this is not a value that I can find by using a binom CDF, because CDFs always start by going from 0 and up to some stopping point. However, I can notice that if this number 0 is the only number that I don't want, what I could do instead is to say that to find the probability that x is greater than or equal to 1, I could take 100%, the total probability, and subtract off the only probability that I don't want, which is, of course, the same as saying 1 minus a binom PDF with 8.30 and 0. So I could actually go ahead and type all this into my calculator, and if I did, I'd end up with a final value of 0.9424. Okay, so hopefully this gives you an idea of some of the ways that we can attempt to try to use these calculator commands to quickly access information from a table that's not even fully completed or filled in. And this is really the power of these calculator commands. One final thing for this video is to note how I'm actually organizing and writing out my work here. Notice that I am writing down all the stuff that I would expect you to write. You would always need to include probability notation. You should always include what you're typing into the calculator, so if you did something wrong, I can maybe at least give you partial credit. And of course, you should give me your final answer rounded to 4 decimal places.